All right, let's have a look at this next assignment. The idea is here we have two parabolas and we have a straight line somewhere in between them. It doesn't really matter too much where it is. I've actually nominated a position. I've said y equals half x minus 2, so the y-intercept is minus 2. But the question is, how can we position this line with this parabola at the top and then afterwards this parabola down the bottom so that there's only one point of intersection? Obviously, if we position it, say, somewhere up here, and we draw a line through, then at this point there's going to be 2 points of intersection. Well, we don't want that. We want 1 point. So it's going to have to be somewhere around here. We're going to keep the gradient the same, and all we're going to change is the intercept. So at the moment it's minus 2. We don't need this anymore. We can just remove this. But we want this to be, so there's 1 point of intersection. And over here, same with the bottom one. We want same gradient, but we want 1 point of intersection. So it's going to be something like this thing here, yeah? So there's 1 point of intersection here. And the question is, if there's only 1 point of intersection for this one, what is this y-intercept? And if there's only 1 point of intercept here, intersection here, what would this y-intercept be? And we have to work out what they would be. So that's what we're going to do. So let's have a look at doing that right now. So first of all, I'm going to restate the two equations. So we've got y is equal to x squared minus x minus 1. Bit out of focus. I'm just going to go take a little bit of focus further in. So it's probably going to be a little bit better to see. All right, so we've got this here. Now I'm going to put the other one. Y is equal to 1/2 x. There it is. Now, in this case, though, because we don't know what the point of intersection is, and if I just left it like that, it would automatically be assumed to be 0, and it's not. It's going to be something other. It's going to be something in between this point here and this point here. So it's going to be either here, giving a point of intersection on this one here, or it's going to be a here, giving a point of intersection like here. But the question is, what is that point? What is that point? Well, that point we're going to call k. So I'm just going to go plus k. So let's go ahead and see if we can find what k is. So the first thing I'm going to do is, because y is equal to this and y is also equal to the thing on the bottom, it stands to reason that y must be equal to y. Therefore, this equation or this expression at the top must be equal to this expression down the bottom. So let's go ahead now and make them equal to each other as we can now. So we're going to say x squared minus x minus 1. Too many ones. Okay. It is equal to half x plus k. I'm going to rewrite that. I prefer x on 2 rather than half x plus k. All right. So the first thing I'm going to do, by the way, is I'm going to multiply everything by 2. I do not like fractions if I don't have to have them. So I'm going to multiply this by 2. I'm going to multiply this by 2 and put a 2 in front of there. And this becomes a 2. And multiply this by 2. And this by 2. And by doing that straight away, we can see that 2 divided by 2 is 1. So to rewrite that, it's rather inelegantly written here, unfortunately. So it's going to be 2x squared minus 2x minus 2 is equal to 2k plus x. So I'm going to first of all subtract x from both sides. There it is. Subtract x from both sides. So now this is going to equal, or rather it's going to be 2x minus 3x minus 2 is equal to 2k. And I'm going to subtract 2k from both sides, minus 2k. So now this equals 0. And indeed, we need to make it equal 0, because if we're going to solve a quadratic, we need to make it equal to 0. So what do we have here now? We've got 2x squared minus 3x minus 2k. So if we were to go through now and say, could we factorize this? Well, not easily, because it's got a k in. Now, if we look at this and think about it in terms of x's and coefficients of x, you see, really, we've got a 2x to the power of 2. We've got a negative 3x to the power of 1. I'm just going to put the 1 in there just for a bit of fun. And this really here is minus 2 minus 2k times x to the power of 0. This thing here is the coefficient of the x squared. This thing here is the coefficient of the x to the power of 1. And this thing here is the coefficient of x to the power of 0. Well, these are in powers of x. as opposed to a normal number, which would be powers of 10. So it's a bit difficult to actually go ahead and factorize if we've got a non-numeric value. Indeed, we've got a k. Now, to resolve a non-numeric coefficient of an x value in a quadratic expression or equation, we need to resolve it by using the discriminant function or discriminant equation or expression. So the discriminant, of course, I could write it as a triangle, or I could write it as b squared minus 4ac. Same thing. We use this is the abbreviation. Now, so let's go ahead and we're going to substitute some values in here. So I know that a is equal to 2, and b is equal to -3, and c is equal to -2 minus 2k. In other words, these are the coefficients of the x values. Now, this, of course, is a coefficient with a non-numeric value. To resolve that, we're going to use the discriminant function. Here it is, so I'm going to say b squared minus 4ac, and this time I'm going to make it equal to something. Well, we're told there is one value. It's going to intersect at one point. Now, just as a sidebar here, if the discriminant is intersecting at no points, it means it's going to be less than 0. If the discriminant is going to be intersecting at more than 1 point, it's going to be greater than 0. And if the discriminant, if the equation is, if the equation is going to intersect at more than 1 point, then the discriminant will be less than 0. If the quadratic equation will be intersecting at more than 1 point, then the discriminant will be greater than 0. And if the quadratic expression or equation, well, equation in this case, would be intersecting at only 1 point, then the discriminant would be equal to 0. So this is going to have to equal 0. I'll put equal 0 way out here because we're going to have a few things going here. So first of all, b squared. What's b? b is -3, so I'm going to put -3 all squared minus 4 times a, well, a is 2, times c, well, c is going to be, I'll put in brackets, -2 minus 2k equals 0. You can see what happens equals over here. Okay, let's simplify this a little bit. -3 squared is 9, minus 4 times 2 is going to be -8, times, I've got a -2 minus 2k, all equaling to 0. Let's expand out the bracket, so I'm going to have a 9. I got -8 times -2 is going to be plus 16. And I've got a -8 times a -2 is going to be another plus 16k. All right. So that all makes perfect sense, yeah? So we're now having an equal to 0, but I'm going to make k the subject now. Well, of course, 9 and 16 is 25, so I have 25 plus 16k is equal to 0. I'm going to subtract 25 from both sides, making 16k equal to -25, and I'm going to divide both sides by 16. Here it is. So k is going to equal -25 on 16. Now, if you want, you could then go ahead and say, okay, well, what is that as a decimal? But I'm just going to leave it as -25 on 16. I rather like that. If I can, I have them as, well, improper fractions or just fractions. I think we're calling them these days. And that would be the value of k. And you want to put a statement here saying if x squared minus x minus 1 and a line with the gradient of 1/2 are to intersect at only 1 point, the y-intercept value of the line would equal -25 over 16. And that's what I would put. And hopefully that makes sense.